So here I've got a poster with inside dimensions of x right here, that's x, and out and y, and I've got the borders are 4 in the horizontal direction, 6 in the vertical direction. And in this question you are asked to find the area that's the smallest. That means that you need an expression. You're going to minimize the area. That means you need an expression for the area. And the area of a rectangle is length times width, and we want the area of the entire poster, so in this entire length and width. So it would be x plus 8, because we've got 4 on each side here, so x plus 8 and y plus 12. There is my area. Next step is you should try and reduce one of the variables, and the question tells you that the inside area is 384. So this area right here is 384. So x times y is 384. And that allows me to reduce one of those variables. I'm going to get rid of the x, get rid of the x in isolate the y here and replace it over there. So 384 over x, substituting it into my equation up here, I get x plus 8 times 384 over x plus 12. Now I prefer, I could use the product rule. I'm going to have to take the derivative, but I think this is just two binomials, so I'm going to quickly multiply this question out and get an expression. So that's 384 plus 12x, that's these two, plus 8 times 100, and maybe I shouldn't write an x there. Eight times 384 over x plus 12 times 8. So that allows me to take the derivative just a little bit more easily, and I'm going to take out a factor of 12 here before I even start, and that leaves me with 40 plus x plus 256 over x. Now taking the derivative, dA by dx is 12 times the derivative of the inside here, which is 1, plus taking, if you imagine 256 as x to the negative 1, it's the negative 1 256 over x squared. And I've kind of run out of room here, so I'm going to move on to the next page. So I've got a prime is 12 times 1 minus 256 over x squared, and I have to figure out the critical points, so where it's equal to 0 or where it does not exist. And I've got, I'm going to write this as x squared minus 256 over x squared, just to give me a common denominator. And the denominator doesn't exist when x cannot equal 0, but x cannot equal 0 in the original question either, because it wasn't in the domain. And where is x squared equal to 256? It's when x is 16, plus or minus 16, but we're not going to worry about the negative because it makes no sense for a negative dimension. So that means x is equal to 16 is the critical point. I'm going to use the second derivative test, which means I'm going to take the second derivative here, and that's 12. Taking the second derivative of this expression, which will be negative 2 times 256 over x cubed. And as long as, and that's a multiplication here, and that means that when x is positive, which we're always going to have, the second derivative is also always positive, so that means we've got a concave up function always when x is greater than or equal to 0. And that means if it's concave up, that means this represents a minimum, because it would be at the bottom of the concave up, because we know this is a critical point to where the derivative is 0. So that allows us to find the rest of the dimensions. If x is 16, then if we go back to our diagram here, if x is 16, then we know that we have to add another 4 twice. So if x is 16, then we have to, our final dimensions, the final width of the poster is plus 8, which is 24, and the final, same thing with the width, this distance right here, will be 36.